Hi, everyone. Well, what we're going to do is this is going to be the start of chapter 4. Chapter 4, we're going to be adding and subtracting fractions. And it is different than multiplying and dividing. So I just kind of wanted to look at when you multiply or divide, here's a multiplication, you reduce, and then after you reduce, you multiply straight across. So in multiplication, we do not have to get a common denominator. You do not have to have a common denominator. But if we add or subtract, you do. And that's what we're going to be looking at in this chapter. And I'm going to try to give you some strategies on finding that least common denominator. All right, so let's say we have 1/3. All right, so here I'm going to take away those. We have 1/3 and we want to add a half to it. Now we're not multiplying them, we're adding them. So in order to add these, the pieces have to be the same size. So this piece, 1/3, is not the same size as this. So we cannot add them together. So what we do is we change this and we want it to be the same size, but different size pieces, but still equal to this piece. And we want this one to have the same size pieces as this one, and yet not change its value. So what we can do is if we have, for instance, let me put this right here on top. What I can do is I can change these two into pieces the size of a 6. So I have size 6 here. And if I were to take 2/6, all right, let me see that. All right. So if I have 2/6 instead of 1/3, you can call it 2/6. It means the same amount. 2/6 is the same as 1/3. And then if I change this, it's kind of like tanagrams, trying to fit them together. I don't need this one. Rather than 1/3 plus 1/2, I can take 2/6 plus 3/6. All right, and now you can add or subtract, or just all depending upon what they want you to do. But here we're going to add these together. So I have 2/6 rather than 1/3, but if they're equal, they're the same size. You've just written it differently with the different size pieces here. So if I take 2/6 and add 3/6 together, I have 5/6. All right. So again, the size of the pieces need to be the same. So in this chapter, what we're going to be looking at is how to go from here to here, all right, to get those pieces. Where does the 6 come from? How can we get the 6, called the least common denominator? And what are some strategies when the numbers are large in order to do that? Now, one other thing, and we'll be working on this in section 4.2, is notice I did not add the denominators. I did not get 12ths. So when you do have a common denominator, which we're going to work on because you need the same size pieces when you add or subtract, but not multiply. Okay, multiply, you just multiply across. But here, when you add or subtract, you have to get the same size pieces. And then how many of those pieces do you have when you're adding them together? And we have 5/6 when we add them together. All right, so, and again, don't add the denominators here. All right, when we were multiplying, what did I do with that? See how multiplying is different. We kind of multiply across. We didn't have to have a common denominator. It happened to be the same, but as when we were adding them, but that won't always happen. But you just multiply straight across. So I think that's why they did the multiplication and division first, is it is a little bit easier. It's not as involved in the steps on how to go from here to here. Well, section 4.1 talks about how to find this number here only. That's all they're interested in, is finding out what this number is so that we can add the pieces together. This number here is called the least common denominator. And in some of your books later on, if some of you take 930, they're going to call it the least common multiple rather than the least common denominator. So just realize that when it does say least common multiple, it means least common denominator. All right, so that's what we're going to do in 4.1 is how to find the 6 and some different strategies when we've got variables. All right, so in some cases, we're going to put variables in the denominator, a bunch of them with different powers, exponents. How is this done? All right, so let's look at some easy ones that maybe you can even just, wow, just look at them. All right, so let me get all this stuff out of the way here. Oh, please stay in focus. So far, so good. All right, now notice, wow, I better go back. Sorry about this. But notice that the 6 was larger than the 2 or the 3. So when you're finding this number here, this least common denominator, it will either be equal or larger than the denominators to start with. In this case, it's larger here, the 6, the number 6 is larger because I'm going to be dividing this by those. All right. So just kind of expect it. They can be equal to those or larger, but like you'll never have, if I had 7/10 plus 1/2, it's never going to be a 2 for the common denominator. All right. So it'll either be equal or larger than those 2 right here when we do ultimately find it. And that kind of helps to distinguish the least common multiple from the greatest common factor, which we'll deal with later. So it will be least common denominator. This number here will be larger than those. All right. Even though that piece is smaller, the number is larger. Hope I just didn't confuse you. All right. So let's look at this one. Oh, they are calling it the least common multiple, but we know it's the least common denominator. Find the least common multiple of each set of numbers or expressions, 3 and 9. So what we have here, these would actually be the denominators of, so for instance, this could be like 2/3 and 5/9. So they're putting these right here. What would both of those go into so that we could have a least common denominator? What would 3 and 9 both go into? Well, this one isn't really too bad. I know that 3 and 9 would both go into 9. 9 divided by 9 is 1. 9 divided by 3 is 3. So it would be 9. All right. So, and again, we want the least. Some of you are like, well, what about 27? 27 divided by 9. I mean, they'll both, why 9 and not 27? Or why 9 or not 18? Because you can take 18 divided by 9 and 18 divided by 3. Okay. You can take 27 divided by 9 and that works, or 27 divided by 3. Well, the key is the word least. They want the smallest number that you can divide both of these into that one right there. So again, you want the least. You could actually get the right answer when we're adding using 18 and 27. You'll have to reduce more at the end. But so try to come up with the least so that you're dealing with the smallest numbers. Okay, let's look at 15 and 20. All right. What would be the smallest number that both of those would go into? All right. Well, there's a couple of different ways you can do this, depending upon the size. One way is to break it into primes. And if you don't know it right offhand, what number that would be. So we're just going to go ahead and practice using primes if we don't know. And this is one that some people say, man, I have no idea what that would be. So we're going to take the 15, and this will also help us with variables when we have variables. And I'm going to break these into primes. The prime factorization is where this comes into. This is 3, times 5. Okay, now those are prime, I'm done. This right here, pick any two numbers that multiplied together give you 20. Let's do 4 and 5. Or you could have used 2 and 10, it doesn't matter. Okay, 5 is done, but this is 2 and 2. All right, so what I now have is this right here is 3 times 5. Okay. And I'm just going to draw a line between them. This right here is 2 squared times 5. Right. So I was just doing this in my 9:30 class recently, and I know that some of them were a bit confused, but I broke them into primes, which is what we did in the last chapter. What you do to find the least common denominator is everything here needs to occur in your least common denominator. So what we do is we look at a 3, and you'll always take the highest power if it occurs more than once. I have a 3 and no other 3, so I'm going to use 3 to the first. Okay, takes care of that. I have a 5 and a 5 to the first. Since they're the same, you'll use 5 to the first in your least common denominator. If you would have had a 5 squared, you would have used a 5 squared. You always have to have the highest power. So we're going to use times 5 to the first. Then we have this 2 squared. So everything here is taken care of here. So there's your answer. 3 times 5 times 4. Or 15 times 4. Or 60. Both 15 goes into 60 and 20 goes into 60. That's your least common denominator. So we're going to practice that idea, unless obviously we know it right offhand by looking at it, like number 6. But we'll be practicing this because this is the idea we'll use for variables when we want to find the least common denominator. What will these go into? And 60 divided by 20, you can do that, that's 3, and 60 divided by 15 is 4. Okay, all right, let's look at 6. Well, this is where it helps to know your multiplication tables. What would 12 and 24 both go into? And in this case, they would both go into 24. 24 goes into there once. 12 goes into 24 twice. So there's your least common denominator, 24. All righty. Hopefully we'll run into one that, to tell you the truth, I'm going to move this down a little bit. I think it's a little bit small. So bear with me here. All right, let's look at 40 and 50. What would 40 and 50 both go into? What's the smallest number that they would both go into? Well, let's say we don't know. We have no idea offhand, so I'm going to break it down into primes and use the idea that we use for number 5. Just, we'll practice that a bunch of times. So here, because Pearson likes to use what I call yucky numbers. So some of the numbers are large, and it's just like, I don't know. For instance, even this one, 16 and 28, right offhand, what would both of those numbers go into? It's not that easy. But if you break them into primes and take the highest power of everything, you're done. So, it's a skill that it can make things easier, especially if you don't have a calculator, which you will not be able to use in your 1500 or your 1000 class. So you do need to know these processes for those classes. All right, so let's look at, I don't particularly care about that pencil. All right, let's look at, we're going to take 40 and 50, and we're going to divide it into primes and use the method that we used here on number 5. So I'm going to break it into primes. 4 times 10, okay? Neither one of those are primes. 2 times 2. 2 times 5. So once I break something down, I usually cross it off. So now we've got primes. In our little tree, we've only got primes here. This is 2 cubed times 5. Okay, I'm going to move the 50 over. So I'm going to have, because I need them a little bit separate so that their trees don't run into each other. So I'm done with the 40. So let's do the 50, break it into primes. 5 times 10, you could have used 25 times 2. Ultimately, you'll get the same primes. 2 times 5. Notice I am using exponents though to write this. That is something that you'll need to do. So I broke it into primes. And so I have 2 times 5 squared. Okay, we're ready to find our least common denominator. Let's start on the left, the furthest to the left here, a 2. I have a 2 cubed. I also have a 2 to the first. You always use the largest whenever they're in common. So I am going to use 2 cubed as part of my least common denominator. And I'm going to cross those off because they're done. I have a 5 and a 5 squared. If they're in common, you use the largest one. 5 squared. Okay, we've used everything up in our trees. We're done. I guess that now the hard part is to realize this is not a 6. This is an 8. So we have 8 times 25. So both of those numbers go into 8 times 25 is 200. That's the smallest number that both of those will go into is 200. Let's look at number 8. And I'm going to use this same method. And so what you can do is you can always stop the video and practice it to see if you can get the right answer, because you really learn by doing, not by watching. So again, here, let's go ahead, and I need another piece of paper. Let's look at 16 and 28 and go through our little process here of finding the least common denominator. So if I had like 1/16 and 1/28, and I wanted to add up those pieces together, you'd need to get them into a common size piece. And that's what we're doing here. So what would that common size piece look like? So I'm going to take 16 and 28. I'm going to divide it into primes. We'll start with 16, 4 times 4. You could use 8 times 2, doesn't matter. I'm going to break both of those into 2 times 2. And 2 times 2. We're done. So the 16 is 2 to the 4th. And again, I have my 28 a little bit too close. All right, let's go to the 28. 4 times 7 is 28. 2 times 2 is 4. So this leaves us with 2 squared times 7. Perfect. So what would both of these go into? What would be a common size piece, to rewrite these fractions with these denominators? Well, I have a 2 to the 4th. Okay, I have a 2 squared. You always use the largest exponent. So we will use 2 to the 4th, and that will actually take care of both of those. Okay. Only thing left we have is a 7. So our least common denominator is 2 to the 4th. So be careful here that you don't write 8 for 2 to the 4th. Make sure you have 2 times 2 times 2 times 2, 4 times. So that gives you 16 times 7. So what's 16 times 7? Let's look at that real quick. 42, 11. Oh, it does not look like a 2. So 112 is the size of piece you would want in order to have a common denominator with those two denominators. That would be your new denominator. Okay. All right, let's look at number 9. I've got 3. I've got 3 fractions, and I want to have a common denominator between 3, 7, and 9. Well, here I have oh, where that came from, I don't know. We have a 3, a 7, and a 9. The 3 is just 3 times 1. The 7 is 7 times 1. So it's just 7 to the first, 3 to the first. The 9, however, is 3 times 3, or 3 squared. So here are my prime factorization for each of these right here. Like if, let's say I had 1/3 plus 1/7 plus 1/9. Okay, what common size piece could I divide each of these into? Well, I have a 3 and I have a 3. They're in common, so you use the largest. Takes care of those, times 7. So your answer is 9 times 7, 63 would be the common size piece, 60/3. All righty. Okay, I'm hoping that you're kind of catching on. If you are, you can kind of fast forward it. But we're going to look at some other examples. I want to make sure that you have this idea down. Oh, let's look at wow. Let's look at number 10. Okay. Again, we have 3 of them again. So we have 12. So we'll have, I'll separate them out. 12, 28, and 32. I don't know if I separated them out enough. Those are my 3 numbers, and I'm going to break them into primes, and I will use the largest power on each of those. Boy, I'm looking at number 12 thinking, I guess we could, oh yeah, those aren't that bad. Now I think we can handle number 12. 4 different fractions with 4 different denominators. All right, so let's look at number 10 first, and then we can do number 12. Here, I'm going to go 4 times 3. The 3 is good, but the 4 is not. It's good practice on your prime factorization. So we have 2 squared times 3. That's what 12 is. 2 squared, because I have 2 of them. That's what we have squared. 28, sorry, is 4 times 7. The 7's good, but the 4 is 2 times 2. I broke it down. So 28 is 2 squared times 7. Let's look at the 32. 2 numbers multiplied together. You could use 16 times 2. I want to use 8 and 4. 4 times 8. 2 times 2. That one's done. This is 2. 8 is 2 times 4. And the 4 is 2 times 2. Wow, look at all those 2's for 32. So this last 32 is 1, 2, 3, 4, 5, 2 to the 5th. All right, so let's find our least common denominator. What would be a common piece I could break those down into? And again, it'll be equal or larger. This number I'm finding will be equal or larger than these right here. Well, we've got a 2. 2 squared, 2 squared, 2 to the 5th. You always use the largest, but it'll take care of all of them. They'll all go into that. 1, 3, 3 to the 1st, and then a 7. Okay. So what is this number? It's going to be kind of large. We can do it though. I know that 2 to the 5th is not 10. Obviously, we know that. 2 times 2 times 2 times 2 times 2 is 32. Times 3 times 7. Okay, so 32 times 3 is 96. And then you take 96 times 7. And that gives you 2, 42, 63, 67 for your answer. So I took 32 times 3 and that answer times 7. And I think that's, yeah, that's right, 63, 67. All righty. So again, there's your least common denominator. All right, you know, to save time on this one, like here, this would be 5 times 10 and break down the 10, 12 times 10, break those down, 15 times 10. So you can do that and break them down into primes and then use the largest. It's just that this video has 3 sections and I don't want it to be too terribly long. And I want to talk about exponents. To tell you the truth, the exponents are easy. You think of it that they've already been broken down into primes. Let's look at number 19. So on number 19 here, if I wanted to, we have a 3 and a 1. So you look at the numbers in front. Let me copy this over. So I have 3x and an xyz. Well, 3, there's a 1 there. We don't write it, but it's there. 3 and 1 both go into 3. Those are your primes. You take the highest of all of them. Then I have an x. Okay, I have an x, and you use the highest power, just like we did with the primes. So x to the first, x to the first. The highest power is x to the first, and that'll take care of that. I have a y. The highest power is y to the first. And then I have a z, and the highest power is z to the first. So they're done just like the primes. You take the highest power of each common base. There's your answer. Okay. Let's look at number 20. It's a bit small. Make it a little bit larger. Oh, yeah, it's kind of straight. All right, so here we have 4 and 6. All right, well, what's the smallest number that both 4 and 6 would go into? And some of you may say 24, but you'd be a little off because there's a number that they will both go into that's smaller than 24, and that's 12. So 4 and 6 both go into 12. So I'm going to have 12 as part of my common denominator. Then we're going to look at the different variables and their exponents. I have an m, and I've only got one of them. So I'm going to just use that one I have. So the highest power on the m that appears here is m to the first. Perfect. That would take care of the m, so it's gone. I have x's. I've got an x squared and an x cubed. You use the highest power, x cubed. And you're done. 12mx cubed is the least common denominator. Because we're going to have these, you're going to have variables for your denominator. So you come up with that. All right, let's look at 21. I've got a 10, a 15, and a 20. So I always deal with these numbers in front. What would 10, 15, and 20, all 3 of them go into? You're like, oh, well, you're not really sure. I'm going to break them into primes. So let's do that. I want a whole new sheet. So we've got 10x squared y, 15x to the 4th y, and 20xy cubed. Let's start with the 10, 5 times 2. So we have 5 times 2, 5 to the first times 2. Then we have our x squared and our y. There's your first number broken down. 15. Oh, see, these aren't so bad. 5 times 3. So here we've got, you can do 3 times 5, 5 times 3, it doesn't matter. They're both primes. X to the 4th y. That one's done. Next, 20. 5 times 4, 2 times 2. 2 squared from those 2 times 5. Order there doesn't matter. Times x times y cubed. Okay, now we're ready. The hard part's done. Now everything here is going to have to occur in our denominator somehow, in our least common denominator. So, we'll just start with something and just kind of work through. Usually when we're doing the variables, I work in alphabetical order. And then write them in alphabetical order. It's not wrong. I mean, xy is the same as yx. Your x times y, 2 times 3 is the same as 3 times 2. But normally we put them in alphabetical, even though ultimately, if you were to put the values in, it won't matter when you finally multiply them. Let's start with 5. Let's go ahead. So we have 5 to the 1st, 5 to the 1st, 5 to the 1st. Now the highest power, 5 to the 1st. Now let's look at a 2. That comes next right here. I've got 2 to the 1st, 2 to the 2nd. So again, we use the highest power, which is 2 to the 2nd. I'm just doing the numbers first, and then we have a 3. And we only have one of them, so we're going to use 3 to the 1st. So I've taken care of all the numbers. They're all crossed off down. They're taken care of here. So now we're going to go in alphabetical order with our variables. I'll start with x. X squared, x to the 4th, x. So this is the highest power, x to the 4th. So really variables are easier than the numbers because you don't have to break them down. They're already broken down into exponential notation for you. I still have a y. I've got a y to the 1st, a y to the 1st, and a y cubed. We're going to use the y cubed because that's the highest one. Looks like we've taken care of everything. All you need to do now is multiply those together. 5 times 4 is 20, times 3 is 60. And there's your answer. So that's how you find, if you don't know by looking at the numbers, what they would all go into, the smallest number they would all go into, you can break it into primes and take the highest power of everything that occurs here needs to take place here. And if you have a common one like the 2, you take the highest power, which is 2 squared. All right. Perfect. That's how you find the least common denominator. So let's go ahead and you can practice that in your homework. We will look at section 4.2, where we're actually going to add them together. And then we'll look at 4.3, which I think might just be subtracting. Yeah, we're good. Okay. So here we go. And again, if this makes sense, fast forward me, whatever works for you. Okay, now what we have here is we're going to be adding fractions. And if you look at 5, 6, and 7 here, the size of the pieces, like what we had here with our 6, we took the 2, 6 plus the 3, 6. Here, the 9, you can't see them there. The pieces are in common here. All of the pieces are the same size, even with number 6, they're the same. So when this happens, resist the urge to add the 9 and the 9, all right? Because, when you're multiplying, you multiply the denominator, you multiply the numerator. But here, once you have the same size pieces, you want to know how many of those pieces, ninths, do you have? So if you have 2 ninths and you add 7 ninths, you're going to get 9 ninths. If you have 9 out of 9, you have 1. So this is equal to 1. That's the answer here, 9 out of 9. Let's look at number 6. The size of our pieces are x. X. Like, oh, you know, and X could be thirds or fourth. You can put any number in here. It's a variable, it can vary, but either way, they're the same. That's what matters. So that when I add the numerators, I get 6x, whether or not it's 6/5, you know, 6/3 or 6/20, you know, well, 6/20 could be reduced, but anyways. So you get 6 over x. Oh, look at number 7, we have a negative. So, but again, our pieces are thirds, they're the same size. So we can keep those here. And also these are like terms. You know, they're both x's, so we can combine the like terms. We have thirds. We have -2 plus 1 is a -1. And you do have that x there. It would be like taking 2x plus 3x is 5x. So that x just carries along with it. So a -1/3 x. So you kept the 3, -2 plus +1 is a -1, because that 1 will take away one of those negatives, but you still have another negative left. And then you have the x just goes along with it. Okay, all right. So let's go ahead and what happens if our pieces aren't the same? Well, we're going to use an idea that we talked about in the last section, but also in section 3.6 maybe, where we looked at getting a common denominator. Well, we changed fractions to a different size. I don't have that example right here, but that's all right. Okay, so what you have to do is you have to decide what will 8 and 12 both go into evenly. Now, if you need to, you can break it into primes. This is like 2 cubed. This would be 2 squared times 3. So you end up actually with 8 times 3, or some of you may know that 8 goes into 24 and 12 goes into 24. So we have a common denominator of 24. So I need to change this to a denominator of 24. And we did this in one of the sections in chapter 3. I'm going to write it here. We're changing 5/8. I want to change it to a denominator of 24. Well, I multiply by 3 to go from here to here. So I have to multiply by 3 to go from here to my new numerator. So I get a 15. All right. So what I did is, in order for the 8 to match the 24, I took it times 3. So you have to multiply the numerator by the same thing. You're multiplying this fraction by the number 1. And when you multiply something by the number 1, it doesn't change its value. So if you have to multiply by 3, you multiply by 3. Here to go, oh, forgot the 2 on 24. To go from 12 to 24, you're going to have to multiply by a 2. That tells you what to multiply by. So multiply by 2 over 2. So you get 24 over 10. So that's how you find that. Whatever you multiply this by, you multiply that by. Okay. So multiply by 3 over 3, 2 over 2. Now I have the same size pieces. They're 24ths. They're real little. It takes a lot of them. So now I can go ahead and add my numerators. And when you add the numerators, you're going to come up with 25 over 24. And for right now, we're going to leave it. We're not going to make it a mixed number. We're going to leave it 25 over 24. So we got some few steps here, but I think you guys will be good. Let's look at number 9 and ask ourselves, okay, these pieces are not the same. Tenths are a little bit larger than the 20ths. 20ths are pretty small. If you divide something into 10 equal portions or 20 equal portions. So we have to have the same size. And what would that be? what would 10 and 20 both go into? Is how we find that common size piece. Both of them will go into 20 because, like I said, this number here will be larger than what you started with or the same as one of them, either the same or larger. Okay, so what am I going to multiply this by? See, here I multiplied by 3 over 3, and this one I multiplied by 2 over 2. So what do I need to multiply the 10 to go to 20? Well, 2. So I'm going to multiply by 2 over 2. Don't make it harder than it is. So I get my 20 and I get 6. All right, what do I multiply 20 to go to 20? Well, 1. Multiply by 1. You get 20, you get 9. So 3/10 is the same size as 6/20. All right, they're actually, you know, the total piece, just like our 1/3 is the same as 2/6. But now I have the same size pieces, so I can add these together. So if I have 6/20 and I add 9/20, you're going to get 15/20. I'm going to put it right here because I'm in the other room. Okay, we have a problem though, in that if you put this into Pearson, it's going to count it wrong. And the reason is that something we did not have to do here, because there's not a number that goes into both of those evenly, you need to reduce these. If there is a number you can divide them both by, you need to do it here at the end. And 5 goes into both 15 and 20. So you do have to divide it by 5 and reduce it. So our total answer is 3/4. Okay, is how we get our final answer. So you're gonna have to ask yourself when you do finish this up, can I reduce it when you get down to the end after I've determined, you know, I've done all of this process here. Boy, isn't multiplication and division a lot easier? You just reduce and multiply across and you're done. That's okay, you guys can do this. All right, let's look at these two. What would 10 and 100 both go into? Well, in this case, I know that it's going to be 100. All right, 100 goes into 100 and 10 goes into 100. So just like here, it ended up actually being one of these here. Now, if you didn't recognize that, break it into primes and take the highest power of everything. You'll get 100. So just takes a little longer. So let's go ahead. No, I have a negative there. That's okay. You'll be fine. Okay, so I know that I'm going to divide, I'm going to have my common pieces are going to be 100th. I would divide whatever it is into 100 little pieces. They're pretty little, but that's okay. Now, you have to multiply this fraction by something over something, this first fraction. And to find out what that is, what's 100 divided by 10? Or what do you multiply 10 by to get to here? So take this divided by this, and that'll tell you, oh, I need to multiply by 10. So division will give you the missing factor that you need to multiply by if you don't know it. So I'm going to take this times 10 and this times 10. And I'm sorry about this right here. Try to ignore this guy. Maybe if I just cross it out. All right, so I'm multiplying by a 10 over 10. All right, so 10 times 10 is 100. 10 times 7 is 70. And to find out what that number is, just what do I need to multiply to go from here to here? And that's what you multiply the numerator and denominator by. Okay, well, the next one's nice because what do you multiply 100 by to go to 100? Well, 1. So you multiply by 1, 1. That times that is that. And negative 29 times 1 is a negative 29. All right. So here we have our common size pieces, 100ths. And so I'm going to take, if I've got 70 and I add a negative 29, how many hundredths would you have? Well, let's see, 30, 41, it looks like. Would it be positive or negative? Well, I have more of these. So I have more positive. So 29 of these negatives are going to take care of 29 of these, which leaves us with 41 positives. Now, what about reducing? Is there a number that goes into 41 and 100 both? And no, 41 is prime. And so it's done. 41 over 100. All righty, let's carry on. Let's do some more. I'd like to do some with some variables. Well, number 11. Let's look at number 11. I have 3/7 y plus 2/5 y. How many y's do I have? Here, the common denominator between 7 and 5. Let's look at that one. And I might just copy this one over because that 11 gets in the way. So we have 3/7 y plus 2/5 y. And so let's go ahead and just look at this one right here. What do I get? Well, we need a common denominator. Yeah, here. And I forgot the y, but we'll put y's there. Those y's just kind of carry down. Okay, 7 and 5. The smallest number those two will go into, they're both prime. And if something is both prime, you just multiply them together. So this would be 35 and 35. All right, so let's go ahead and find our new numerators. Now here, to go from 7 to 35, you multiply by 5. So I'm going to multiply by 5. I have to multiply that by 5. Okay. So that gives you 35. That gives you 15. Done. Let's go to the next one. To go from 5 to 35, I multiply by 7. So that means I'm going to multiply by 7 over 7. I'm multiplying it by the number 1. When you multiply, 7 over 7 is 1. And when you multiply a number times 1, it doesn't change its value. It's changing the looks. So 7 times 5 is 35. 7 times 2 is 14. I now have a common denominator. Many steps here, but you guys will it just takes practice, that's all. So I got a common denominator. What do you have to multiply by? You know, this number is determined by how do you go from 7 to 35? This number, how do you go from 5 to 35? That's what you're going to multiply the numerator and denominator by. So, common denominator, so 15 plus 14 is 29. And the y goes. If you forget the y, Pearson will count it wrong. You've got to carry that variable through. And see if you can reduce it. 29 is prime. And so you're done. 29 over 35. Let's try another one here. Let me see. I kind of wanted to do one with variables, but I don't think they have it. So let's just kind of look. I'm hoping that you're kind of getting this. Let's look at 13 here. And we could do 12. Let's just go ahead and do 12 and 13. And then we might look at one of these with 3 variables. But let's look at number 12. 4 and 10. You have to ask yourself, okay, what will 4 and 10 both go into? What's the smallest number? Well, they both go into 20. You know, I just kind of went through my mind. I'm like, okay, 10, 20. Oh yeah, 4 goes into 20. If you don't know how, you know, if that 20 was tough, put them into primes and take the highest power of everything. Like break that down into 2 times 2, which is 2 squared. 2 times 5, and then take the highest power of everything. But either way, you're going to come up with 20. So we have 4 plus, oh, sorry. Well, I was going to let me copy it over. All right. So here we've got, we want a, all right, so we're going to go with 20. All right. Okay, what do you multiply a 4 by to go from 4 to 20? What will I multiply that by? And if you don't know, take 20 divided by 4. That will tell you the missing factor that you need to multiply by to get back to the 20. Well, 20 divided by 4 is 5. That means I need to multiply by 5 over 5. All right. And when I do that, 5 times 4 is 20. 5 times a negative 3 is a negative 15. Awesome. We have it. These two fractions are the same size. They just look different. To go from 10 to 20, I multiply by 2. So you always match, it's 2 over 2. So 10 times 2 is 20, 1 times 2 is 2. So now I have the same pieces. My size of my pieces are 20ths, and I have a negative 15 plus 2, which is a negative 13. Because 2 of these will take care of 2 of those negatives, so I'll still have 13 negatives left over. Always ask yourself, can I reduce this? And no, 13th prime, there's nothing that goes into 13 and 20, so your answer is a negative 13 20ths. All right, let's look at another one. Let's look at 13. It's kind of a trick one here. And I want you to get used to that. It's really important that you understand what 0 over 15 represents rather than 15 over 0. So here, this 0 over any number is 0. And if you take a number and add nothing, you still have just that's what you started with. So you have 3/5 plus 0 is still just 3/5. Now I want to try, we're going to do a story problem that's going to allow us to work with 3 different fractions. I guess these are, applications. It's good to have some applications of some things here. And then we'll look at subtraction and then I'll be done. Now, what we have is 1 week, the snowfall in Plainville was 7/8 inches on Tuesday, 3/4 on Wednesday, and 9/4 on Friday. Altogether, how much snow fell that week? So they want to know the total amount of snowfall. So you're going to add these fractions together. So you'll be taking 7/8 plus 3/4 plus 9/4. When I add these 3 together, these 3 numbers, these 3 denominators need to be common. So what will 8, 4, and 4 all go into? And what will be the smallest number? When you find the smallest, the least common denominator, you don't have to reduce so much at the end. Well, they all go into 8. So I'm going to change them all to an 8. All right, well, the first one, what do I multiply 8 to go to 8? Well, that's 1. So times 1 times 1. So I end up with 7. Let's go to our next fraction. What do I multiply the 4 by to get to the 8? 2. So I'm going to multiply by 2, multiply by 2. So I get my 8 and I get 6. What do I multiply 4 by to get to 8? 2. So times 2 times 2. So I get 8 and then 18. So they all now have the same size piece. So I'm going to add, I've got 7/8, 6/8, and 18/8. How many 8s total do I have? So when you add these together, let's see, I'm going to add this one. It doesn't matter the order. And I know that if I add these two, I get 25 plus 6 is 31. 31/8. Or, you know, you could take 13 plus 18. Doesn't matter the order. You're going to get 31/8. We're not going to make it a mixed number right now. So we're just going to leave it as 31/8. Okay. All right. So the same thing for this 21. You're going to panache, bought 1/4 pound of buttered popcorn or buttered popcorn jelly beans. Oh, yay. 2/3 pounds of root beer jelly beans and 3/8 pounds of green apple jelly beans. How many pounds of jelly beans did he buy total? Well, you're going to have to take 1/4 plus 2/3 plus 3/8 and to find a common denominator between 4, 3, and 8. In this case, they all go into 24. All right, 24 is you could break them into primes. What are you going to multiply the 4 by to get to 24? Well, you're going to multiply by 6. It's not coming out as clear as I'd like it to be. So you're going to, that's a 24. The table's a little rough. So to go from 4 to 24, you multiply by 6. So we're going to multiply by 6/6. That gets you your 24. 6 times 1 is 6. To go from 3 to 24, you multiply by 8. So we're going to multiply by 8/8. That gives you 16/24. And then to go from 8 to 24, you multiply by 3. So we'll multiply by 3/3. And multiplying, you multiply across. Okay. So again, you have your size of pieces are 24ths. How many of those total do you have? Let's see, this would be 31 again. 31/24 is what that one comes out to be. All right, so I'm hoping that this process, sometimes the hardest thing is coming up with the 24. After that, it's pretty simple. All right, and you can use the greatest or the factorization in order to do that. Okay, there's one more thing in this section that we need to do, and that deals with comparing fractions. But to tell you the truth, what they want you to do in this section is to get a common denominator and then compare the numerators. But to tell you the truth, I think that getting it as a decimal is probably the easiest. So here, well, obviously here you don't have to, there you have a common denominator. If you have 3/10 or 7/10, which one would be larger? What would be a larger chunk? And the 7 obviously would be larger. Okay, so you have the open end towards the larger number. But now what about this second one? -5/2 and a -8/5. What I would do, it would be to change these to a decimal. And how do you do that? Well, just take on your calculator, just take 5 divided by 2. And when you do, you get 2.5. So here you have a -2.5. And you're comparing it to a -8/5, which is a -1.6. And remember, on the number line, as you move further to the left, it's smaller. This one is to the left on the number line. Okay, is this one. So here, it's like that. I would do the same thing with 3/8. 3/8 is 0.375. 9/20 is 0.45. So if you have 3/10, or this is the 0.4, this one is larger. And we'll be working on that a little bit more too when we get to the decimal chapter. Okay, so that is 4.2. I do want to do 4.3. All right, I'm trying to keep down the number of videos. This one right here, it's the same thing as the addition. You got to get a common denominator. But what you might want to do here, especially with negatives, let's do number 8. Well, no. Let's do 5, 6, and 7. We won't spend too much time because the steps are the same. All you do, this is actually similar to addition. Remember, we change this to addition and we change that to a negative. So we go make this addition and change the sign on the opposite. Make the next number the opposite of what it is. So here you're going to have 6/15. But then of course reduce it because 3 goes into both of them, 2/5. Here plus a negative, so it's just like the last section, just this one little step right here. So we have 1 plus a -7 is a -6/9. And then obviously you have to reduce it because 3 goes into both of them. Divide by 3, divide by 3. Okay, let's look at number 7, plus a negative. It's an addition one. Denominators are the same. 7 plus a -3 is 4. All right, so this part is the same. You just have this one step plus a negative. You change it, plus, and then change the sign on that following numerator. Okay. All right, so I think maybe from there you guys can figure that out. One thing that is very important in this chapter is 14, 15, and 16. So here, this is an equation, and when you have an equation, well, you can get rid of the denominators here. But I think because we only have this one fraction, what they want you to do is to subtract 2/5. To get rid of this is plus 2/5. So you can subtract 2/5 from both sides. So to get rid of the plus, you have a minus. And then you have to get a common denominator and subtract those. And what we're going to do eventually is we're going to look at a different method of solving these. But from here, to practice subtracting, I have 9/20 minus 2/5 is the same as 9/20 plus a -2/5. Get a common denominator and add them together. We're actually going to end up subtracting the numerators here. But let's go ahead and finish it. This is the end of my video. To go from here to here, you multiply by 1. So you multiply by 1. To go from 5 to 20, you multiply by 4. Okay, because 20 and 5 both go into 20. So you get 20 and a -8. So this gives you 1/20. All righty. So that's how you would do these right here. Let's look at number 16. Make sure you understand this. I want to get the variable by itself here. So I have t plus 1/8 equals -5/6. So I just copied it over, makes it a little bit larger. Now to get this by itself, whenever it's plus, you're going to add the opposite. If it's multiplication, we would be doing the reciprocal from the last section. So negative 1/8, negative 1/8, or subtract. Subtract is the same idea. T equals negative 5/6 minus 1/8. This right here is plus a negative. You get a common denominator. What does 6 and 8 both go into? 24. I guess knowing your multiplication tables, it helps a little bit. So to go from 6 to 24, you multiply by 4. So you get 24, negative 20. Negative 5 times 4 is a negative 20. 8 to 24 times 3. Oh, I don't know why I put in 2. Times 3 times 3. So you end up with, seems like there's kind of a glare on that, but negative 3. That times that. Okay, so now we have the same size. Combine our numerators. If you have a negative 20 and you add 3 more negatives, you get a negative 23. Okay, well, I think that's probably enough for right now. You know, I just keep telling you, please let me know if you have any questions, whether or not it's about Pearson or, you know, adding and subtracting denominators, please let me know. Otherwise, I'll just get another video out, and thank you.